So we're going to apply inverse to solve these. So the first thing is we want to work outside in, so I'm going to undo the log function with an exponential function. So I end up with a to the power 0 is equal to the arc sine of x plus 1. Okay, a to the power 0 is equal to 1, so we end up with the arc sine x plus 1. 1's cancel, so we end up with 0 is equal to arc sine x. Okay, now the x is going to be an angle. Okay, sorry, it's a ratio. 0 represents the angle. Okay, so when I draw this out, I should have a visual idea of what I'm working with here. I've got my picture here. I've got my ratio. My angle is 0. Okay, so I need to work out what my ratio is, my sine ratio. So the angle equals 0, so we end up with sine 0 is equal to the value of x. So sine 0, or the sine value at the angle 0, is going to be x equals 0. Okay, so the sine value at that point is equal to 0. And the angle part of this, I'm just going to highlight that this is an angle of 0. Okay, and that's going to be my 0 angle in here, 0 radians. For this next one here, we do have to be a little bit careful because of the domain of, the range of the cosine function. Okay, sorry, the domain of the cosine function only accommodates, the arc cos only accommodates -1 to 1, and the range, we need to limit the range. The range is limited to -pi/2 to pi/2. So when we look at the arc cos, we have to be careful because the arc cos function is only valid for these angles. Okay, this is the output of the arc cos function. So when we undo the arc cos, we have to make sure that that's part of the domain of that function. So I'm going to undo the arc cos with the cosine function. So I end up with cosine of pi/4 is equal to negative cosine of 2x. So I can plug that in. I end up with cosine of pi/4. Okay, cosine of pi/4 is going to be this value here, 1/√2. And that's going to be equal to negative cosine of 2x. Okay, so the cosine is valid for all different angles. Okay, so when we solve this 2x could be, the domain of this 2x is all real numbers. So when we undo this, we have to account for that when we undo this. So when I solve for x, so first of all I'm going to move the negative to this side. Okay, so this now I'm going to use this picture of cosine, and 2x then represents my angle. -1/√2 represents the ratio. So it's going to be in these two positions here. Okay, and I'll do this in two different colors here. There's my θ1, there's my θ2. Do θ2 in a different color. There's θ2. Okay, so those are my two angles for 2x. So I end up with, for θ1, okay, so 2x in quadrant 2, which I'll call θ1, that angle is going to be 3 pi/4, or 135 degrees. Okay, solving for x, we end up with 3 pi/8. Now we have to account for the period here. That period is going to make this period pi, so we're going to end up with repetitions every pi. And that is for this angle right there. For the other position, we'll call that θ2. Okay, that's going to be equal to, that looks like 5 pi over 4. Solve for x. X is equal to 5 pi over 8. And again, the repetitions are going to be in terms of pi, so there's my solution. Just a reminder that we have to be able to be conscious of the range of the arc-cos function is only from negative, I think I made a mistake. It should be from 0 to pi. That's the range of the arc-cos function. When we use arc-cos to solve, okay, the cosine has an unlimited domain, so when we solve that, we have to account for all the repetitions. Okay? So last one here, we want to undo these different functions. We're going to undo the log. We're going to use an exponent to undo the log. So exponent 1 base pi over 2 is equal to cosine, arc cosine of cosine x. Okay? So the arc cosine, when I think of the domain of that arc cosine, the domain will be, so the range of the arc cosine is going to be from 0 to pi. So the arc cosine, the cosine value, when I undo this, so I'm going to undo this with cosine, I'm going to undo cosine pi over 2 is equal to cosine of x. Okay, now because the x value, and cosine being a repetition function, the x value can actually be not just pi over 2, but there are actual other values. So when we undo that part, we can actually work this out. So we're going to end up with 0 equals cosine x. Okay, and this is the reason why this shows up is because the arc cosine and cosine aren't perfect math inverses of each other. So we can't just say this is equal to that. We can say that the cosine pi over 2 is equal to 0. Okay, but for cosine, we can have cosine can be here and here. Okay, so then we end up with solving for x. X is equal to pi over 2. X is equal to 3 pi over 2. There are repetitions of this, so plus n2 pi plus n2 pi. Okay, so those are my solutions for that particular equation.